All right, you should try problem number 1 on 5-7i, and then pause this video. So when you get done with this, then you should go ahead and try this. I will show you how to do problem 5-7i. All right, so pausing. All right, now here's how you do 5-7i. 5-7i, problem number 1. Problem number 1 has a box which weighs 1,000 newtons. Is lifted a distance 20 meters straight up by a rope and pulley system. The work done is done in 10 seconds. How much power is applied? Power equals energy divided by time. In this case, you could use potential energy or work. I'm going to go ahead and use work because there's work in the problem. So that's force times distance divided by time it takes to do it. The force in this case is 1,000. 1 times 10 to the third times the distance, which is 20, divided by time it takes to do it, which is 10 seconds. And I get a whopping 2,000 watts or 1 kilowatt. Okay, pause this. I'll do problem number, when you get to problem number 3, we'll go ahead and do that one together. Okay, I'll do problem number 3. Go ahead and do problem number 3, and then when you're done with problem number 3, come back to you. All right, now I'm going to try to show problem number 3. Problem number 3. Rock climber wears a 12-kilogram knapsack while climbing and scaling a cliff. After 30 meters, the climber is 8.2 meters above their starting point. How much work was done on the knapsack? How much power was applied on the knapsack? Okay, so work is equal to force times distance. In this case, we're talking about the force of weight times the height. Force of weight in this case is going to be 12 times 9.8 times the height, which is going to be 8.2 meters. So the amount of work done is going to be 12 times 9.8 times 8.2. And the amount of work done is going to be 964 watts. No, sorry, joules, because we're talking about work, right? Now if I want to find the power is equal to energy divided by time. So 964 joules divided by the time it takes to do it, which in this case is 30 minutes, which we do 30 times 60 because we need seconds, right? So divided by 30, divided by 60, and this person's is only delivering 0.54 watts. That's what she's delivering. All right, try problem number 4. Unpause this on problem number 4, and I'll show you how to do problem number 4. All right, problem number 4. Problem number 4, electric motor develops 65 kW, so that's kilowatts, of power as it lifts an elevator 18 meters in 40 seconds. How much force does the motor deliver? Okay, so power equals energy divided by time. Okay, in this case, we're talking about lifting an elevator. So I'm going to go potential energy this time because it feels like a potential energy problem. Potential energy problem is mgh over time. Potential energy because it's lifting, right? The mass is, oh, wait, it says force. Wait, force, bad choice, bad choice. Let's go work because work has force in the equation, right? So force times distance divided by time is equal to the power. All right, so now I'm going to get this up my equation. Force is going to be what I'm looking for. Distance is going to be 18 meters. 18 meters divided by time it takes to do it, which it says it does it in 40 seconds. So how much power? And the power it says is 65 kilos, so I go 1,000 watts. Okay, so then I'm going to get my force is equal to 65,000 times 40 divided by 18, and I get a whopping 144,000. My pen, there it is. 144,000 newtons, and there you are for how much force is developed. All right. All right. We're going to do 5. So go ahead and try number 5, and then I'll do 5 with you, and then the rest of the worksheet will be yours to play with on your own time. But go ahead and do number 5. So pause, do problem number 5, and I'll get back with you. All right. Problem number 5. We have a gardener applying 150 newtons on to push a wheelbarrow 60 meters at a constant speed for 20 seconds. What's the power of the Gardner in watts? Okay, so the power of the Gardner in watts is going to be, he's applying a force for a distance. So I'm going to go work again, divided by time. So work in this case is force times distance divided by time. So then I want to know how much power it is, so I'm going to keep going with this equation. So force is 150, 60 meters in 20 seconds. So that's going to give me 450 watts. Yeah. What is the power of the Gardner in watts we just did? What's the Gardner's power if the speed is doubled? So I go back to my power and go, well, if my speed is doubled, then my time would be, or my distance would be, so my force is to be 150, but I could double my distance, right, in the same amount of time. Okay, and that gives me 900 watts. Okay. Also, it's an interesting thing. If I'm going at constant speed, this typically happens when you're going maximum speed for a car or something like that. You got force times distance divided by time. You can regroup this as force times distance divided by time. And if it's constant speed, it'd be force times velocity. So if you're going at constant speed, whoops, my pen just did bad things. Okay, sorry. Okay, so my force times velocity is a way to find out what my power is. Okay, and so that's why power is so important in engines. People that love cars want to know how powerful it is. That's because your frictional forces are fairly constant. So the more powerful your engine, the higher your speed can be. Okay, and so if you're at your top speed going at constant velocity, the amount of force times that speed is equal to the power that you have at that time. All right, the rest of the problems are yours. Meet you back for another video in just a moment.